Good morning, everyone. Welcome to session 5 of the JCDREAM Symposium series. Today, we are going to start off with the information session for the 2021 JCDREAM Seed Grant Program. And after that, we will hear from our main speaker, Brian Kraft and Aaron Feber on building university industry research partnerships. I'll turn it over to Aaron to introduce our next speaker and take it away.
So without further ado, Brian Kraft is the Assistant Vice President for Innovation and Research Engagement within the Office of Research at Washington State University. Within this role, he is focused on building research partnerships with public and private sector interests that serve to translate innovative research at WSU into meaningful societal impacts. Brian has a long track record of building successful collaborations in areas ranging from research focused on technology commercialization to the development of student training programs to the implementation of organizational change initiatives. Specific WSU initiatives Brian is currently leading include the efforts to implement recommendations of the External Review Innovations and Entrepreneurship, an effort to support and incentivize students and faculty to embrace a culture focused on impacts and outreach, the Entrepreneurial Faculty Ambassadors, or EFA program, which serves as a faculty networking group to disseminate best practices and connect experienced and aspirational faculty focused on public engagement, and the WSU I-Corps site, which is a training funded by NSF focused on helping scientists and engineers evaluate product market fit, and then the Small Business Development Center, which represents a statewide network of 30 small business advisors funded by the SBA. In addition, the Innovation and Entrepreneurship Initiative, which aims to better integrate technology-focused economic development with undergraduate training in entrepreneurship. And Brian holds his undergraduate degree in biology, chemistry, and a PhD in chemistry, and has served Washington State University in roles ranging from technology evaluation to programmatic development over the last 14 years. And with that, I give you Brian Kraft.
Thanks, Aaron. Let me go ahead and put my slides up. I've got a talk that's kind of a mixture of how you find the right company, how you find the right person in the company, and then what you do when you talk to them. And then lastly, it goes into the process that you need to go through to actually move it through the university and some of the things that'll come up. I'm not sure I'll get to it all, but I prefer to have a very conversational presentation style. So if anybody has a question or wants to make a point or pipe in, please do. You can do that by way of the chat or just raise your hand. So as Aaron mentioned, kind of my area of specialty for the university is building these types of partnerships. It's actually kind of a challenging thing to do because when you look at the organizational mismatch between university and company, there's a lot of gap areas where we just think differently or we aren't to interact with them. We're typically the university is this large, pretty rigid organization. They're organized and designed to develop and research federal grants. So they've built everything around that, but really what industry needs is customized solutions, negotiated projects, not the things we typically do in going after federal funding. So when you think about working with industry, you have to think about it very differently. It's very relational. You need to go in, start meeting with people, learning about needs areas, and then start massaging the interaction to get to the place where you could find mutual value, where there's something that you intellectually as a scientist want to work on and adds value to the other organization. So it's a little bit different than what we typically do in the university in going after federal RFPs. It's really important that you understand that difference. You don't see calls for proposals from companies very often. You have to find them. And the same thing is true when you're engaging with an organization like JCDREAM and you're trying to find a partner to bring forward into the discussion. So, it's hard work and it takes a lot of energy to get the interaction up and running. So why even bother? When you look at the data around, people have industry collaborations. What you see is that their publications usually have more impact. There's more noise around their work in terms of references. The other thing that I like to point people to is the success rate. When you do get to the point where you actually have a proposal that you're ready to put in with industry, your hit rates are a lot higher. You don't get turned down as often. But there's a reason for that, because the way you actually develop the project is you presuppose it, or you pre-position it for funding by developing it from the ground with your collaborator. So there's a lot of steps in this. You first kind of need to find the right person to talk to. You then need to get engaged in a conversation about what their needs are and where you have a value to them. And then that leads into starting to bullet out, a set of deliverables that meets your interests and theirs. And then you got to go through the funding and the contract and all those other things. So, usually in this process, what you're doing in those early stages is you're figuring out, how to build the proposal to them, not how to build the proposal to you. And because you're doing that, usually you're bringing in a product that is already aligned with what their interests are. Typically the proposals that go into industry that I see, 1 to 2 pages with some bullet outcomes, right? Really, really simple documents. But they can be that way because you don't have to go through the whole process of, convincing them around your science and doing the background. It's not 15 pages of a NSF proposal. It's a 2-pager that's to the point, solves a problem. So what you really need to do is kind of understand your audience, figure out what your message to your audience is, and then get focused into where the problem areas are. A different way that people like to use this, is this little acronym AMO. First identify who you're talking to, then figure out how to talk to them. And by that, I mean, understand the language, their jargon, how they use it, and how it's different than what we do in academics. And then mechanism, what's the best way to get to them? And it might be different, right? In some areas, it might be email, in some it might be some social channel. In others, it might be you need to go to this conference. And then the last thing is to really define what your outcome is. What do you want from them, right? Do you want them to take something you have developed? Do you want them to work with some expertise that you have to get to a project, right? What's the take home, or what action are you calling them to? So what I'm going to do from here is kind of walk through the different parts of that. First one is really finding the company. It's identifying who your audience is. And more importantly, why do they even care, right? So the best way to do this kind of stuff is just really high-level market research, right? The keywords around your technology. What does the market think about it? And when I say market research, I literally mean use the words market research around technology in your Google search, right? Start understanding who the players are in the market that you think you're going to hit, and then use that to go deeper into what the interests of those companies are. A lot of times, your initial assumption is that your work would be of interest to Boeing, right? Because it touches some component that is important to operational. But in reality, it's not Boeing. It's somebody that Boeing contracts with to buy something from, right? So you need to do that kind of digging to figure out where the right collaborator is. Where specifically does your work go into one of these verticals that ends up in an airplane? Right. So that's kind of part of the point of market research, right? You sort of understand what the market looks like, understand kind of who's involved in it, identify where you sort of fit in that, and then go find the individuals that you want to talk to. And that's kind of what we're going to walk through. And this is sort of redundant. It's different ways of looking at the same thing, right? I'm starting to, at the beginning, you're kind of just fishing. You're out there looking around, seeing what information is out there, and then you're going to narrow down the funnel to find the specific person that you want to talk to as you learn more about the market you're hitting. Google's a great start point. This is always where I start from. When I start to understand a little bit more of the market, I'll go to our libraries and use some higher end systems, and please leverage your librarians. They're there to help. They know all these tools backwards and forwards. If you come to them with 3 or 4 specific questions or companies that you want to research, they're going to expose you to bunches of tools. But experiment in Google and play with different keywords and start evolving how you describe your technology to match what people write about the markets you want to hit. So get less academic, get more sort of secondary literature is what you need to do in this space. So once you've got a reasonable idea of the companies that you're hitting, you then need to go find the people. A couple of different tools, few comments on people. The first thing you want to be thinking about is what's the right kind of person to talk to. For example, you don't go to Boeing and talk to their vice president of technology, right? Just way too high level. Similarly, you don't want the entry-level scientist. You're looking for somebody who's kind of mid-management title type. You're looking for somebody who's got the bandwidth to talk to you, but also some kind of decision-making authority around what they do in research. So some of it is fishing around with titles and understanding where people sit in organizations. So there are all kinds of tools out there to do that. Some of it involves activities like LES and others, but a lot of it is in places like LinkedIn. LinkedIn profile, if you don't have one, you're wanting to work with industry, I would very highly encourage you to go establish one. It is a super powerful tool to find people, and I'll walk through a couple of the different ways that you can use it to do some searching. Most of these, like anything else, it's sort of not a linear process. You need to experiment with it, mess around, try different angles on getting at different people. Again, I'll walk through some of that. A tool I find very useful is this Web of Science, and I'll show you some aspects of it that help you sort of search company. It is behind a paywall, right? This is something that the WSU library subscribed to. My guess is that most of your institutions have a tool that looks like it. And again, I would do not be shy about reaching out to librarians on this. The business librarians love to help with stuff like this. Last one we're going to touch is the Google patent search. So Google Advanced Patent Search is a very powerful tool. This is really useful. Let me back up. LinkedIn is about finding people. Web of Science, this is now you're doing sort of company research where you're understanding where they publish and who they publish with. And you can also find people there by names of authors on relevant literature that you find. A different way of doing that same thing is looking at the patent literature. There's 2 different directions you can kind of think about the patent literature. One is, who's technically active in a space. 2 is, what are the names of the people in the company who are active in that space? So we'll walk through each one of these 3 briefly here in a minute. But before I do that, I want to just jump to reading patent literature. I don't know how many people here in this audience are used to it. It's a little bit different. I don't know if when you read patents, you often get lost. I like to point to some of the key information that people can use to inform you about what a patent actually means. Patents are written in obtuse language on purpose. First thing I look at when I see a patent application or I'm looking at the patent literature is I ask myself the question, is it a patent or is it an application? Because those are very different things. Patents have numbers. I think we're in the 10 millions at this point, but usually in the PDF version of the publication, it's up in that corner. You want to look at priority dates. When was it filed? This is all important because patents are tools that can block you from doing different technical things. So you kind of want to know, if you have your own patent, how this patent relates to yours, or if you're thinking of working in an area, knowing what is covered. The meat or the center part of the patent is usually written what they call the specification, and it's a detailed description of the thing that is being claimed or invented in the patent. The part that I really focused in on are the claims, because the claims at the end are what they legally draw boxes around and define as theirs. And one of the things I mentioned earlier about application versus patent is a patent claim is only valid once it's issued. So once it's assigned a patent number, now it's a legal claim that the patent owner has around it. Aaron, did you want to pipe in on some of that?
Yeah, I will. I think I love all the stuff that you pointed out, Brian. Also, there's a few other things that I would point out as well to help you guys, having written a few dozen patents myself. So if you go back to slide 20 real quick, Brian, there's a few other interesting pieces of information you can get here. First off, right there, it says prior publication data kind of in the middle of the left-hand column. That's the numerical format for a patent, for an application that hasn't yet been granted. So you'll see that as a patent application, which means that, you know, it's still kind of in draft form, I guess I would say it that way. Another interesting thing that you'll see is they're citing US patent documents and other publications there. So the researchers or inventors that, you know, are filing this application or this patent, that's kind of like this works cited section of a scientific publication. These are other areas, other publications and other technologies that they think are adjacent, perhaps interfere or overlap with their own technology. And some of it is the scientific literature. So you can get a feel for who in the scientific literature, who maybe your colleagues are or competitors that are adjacent to the technology that the inventor has filed for here. And I guess, you know, the other thing that I'll just point out is recognize that if you've gotten a patent issued, a company has probably spent at least $100,000 on making that happen, sometimes as much as $500,000. And so it's a big investment. And so you got, you know, I think that's part of why we're pointing this out, is it's something where they've kind of put their money where their mouth is, and they care about this particular technology quite a lot. The abstract gives you a good overview. And then if you go to the specification page, Brian, I don't think we have it outlined, but a lot of patents will contain a section called examples. And so if you read the examples, that's typically, it's kind of like the experimental section of a research paper where you say, hey, this is how I made that. That's how you describe what the invention is and how you achieved it. And you have to experimentally go through a whole lot of details. So if you're looking to reproduce somebody's results or mimic what they've done, well, you can't quite do that, you know, and go out and sell it. And that's why they have the patent in the first place. You can get a lot of scientific details about how they're achieving their invention in that experimental details section. So just a few more.
Yeah, I want to point out that on the examples in particular, it's hugely variable by field. Yeah. When you're talking about electrical engineering or computer science, those filings and those examples are still, they remain very obtuse because the patent office looks at those as very predictable areas. So you don't need many examples to get a lot of claim space. When you drift over into chemistry, material science, biology, the examples become very much like a scientific experimental write-up. So you see a lot of variance, but that's a good point, Aaron, because the examples are kind of what allows people to get claim scope, and in fields like materials science, that's super important. So I'm going to jump over to a different screen real quick and walk through a couple of those tools I was just sharing with you or mentioned. Let me get this one, screen 3. Okay, so are you looking at patent search, Google Patents? Yeah, okay. So if you just Google Patents Advanced Search, you'll find this page. It'll be the top hit. I find it a useful tool because you can both search by keyword, search by company. You can sort by when they filed. Assignee is the patent word for the owner. So we'll do a little quick search. I just kind of mimicked up one thinking about JCDREAM, and so I did this. Ion. Oops. So you could use your own keywords here, but just some things to note. So Google Patents, I like to always go to show me 100 so I can just scroll down, because a lot of times, when I'm using a general keyword or a general keywords about the work that I'm interested in, I'll find my interesting one and hit 70. So some neat things that you see here. They tell you who kind of the top companies are associated with the keyword right here, and you can click on these to get to that company specific filings. I know Ballard, that's got a Northwest footprint. So if you take a look at this, you see, okay, now here's a breakdown of Ballard filings. In these lists, it lists inventors and the companies. What I note here is a lot of these top hits are really old. And say I'm interested in talking to Ballard about ion exchange membranes, and I want to find who's recently active. I'd then filter it to the filing dates of maybe 2018, 2021. Now I'm going to have a list of Ballard filings in the last 3 years. Or wait, filing in the last 3 years. That didn't do that. Oh, that's why. There. So these are things that were filed in this time frame. You see the filing dates here. What I'm noticing is that I'm seeing a lot of the same name. Right now, I've got not only the technical area of the company, but I've also got a person in that technical area and company that I can then go use in some of the other tools around. So this is kind of how I would use Google Patents to find a collaborator and find a specific person. Aaron?
I like that you brought this one up, Brian, because this sort of was a good one for me personally, because it highlighted an area where I was kind of ignorant on the language that's used in a particular industry until just like maybe a year ago or so. I said earlier, I'm a battery person. So I've focused on battery materials and assembly of batteries. I don't know that much about electrolyzers and fuel cells, but I'm trying to get smarter about that. A couple of these top ones right up here, you notice they use the term membrane electrode assembly. So that's a technology that you see in fuel cells and electrolyzer technologies. It's an acronym, MEA. And, it was one of those where I started hearing people rattling off the acronym MEA. And of course, you always, sometimes you're willing to ask a question about what an acronym means, which you should do, by the way, because everybody uses acronyms, a little too much. But it's a good way to kind of key in on what the industry vernacular is and how are they talking about this. And it helps that, again, makes your searching and your ability to find technology much more powerful when you kind of hone in on that particular that language or the types of phrases that they use to describe the technology.
Yeah, good point. And that gets back to the messaging and making sure that the words that you're using are going to fit with the words that they use when they describe something.
Yeah, and when you talk to somebody and you use their same language, you sound like somebody who's in the industry, who knows what they're talking about, and they're just going to relate to you a lot better, right? It becomes it's a powerful technique, more so than you would think.
Simple but very important. So this is kind of just a snapshot of how you use Google Patents. It's a great way to find who's technically active and what companies are relevant to the specific technical words that you're looking at. Another one that I find super powerful is this Web of Science. Now, again, this is behind a paywall at WSU libraries, but there are probably similar tools at every university. So it's a matter of going to a librarian and saying, what tools do we have to do research on what companies are researching? So the tool that I use, you obviously want to get to, more recent information, last couple of years. This particular filter has this organization enhanced one. Now I'm looking at companies. One of the reasons I like this tool is it allows you to get a quick snapshot of their academic collaborations. When I bring a new company into WSU, one of my first questions in my first meeting with them is, how often have you worked with universities? And the reason I ask that is because of that big cultural mismatch. And so I want to get a gauge on how savvy they are in working with universities and how much hand-holding they're going to need. So I like this tool because I have a quick example. One of the companies that we are interested in here in the Northwest is Avista, right? And we have a lot of interaction with Avista, but what's interesting is when you do this and look at where Avista publishes, they basically don't. So, you can tell right off the bat that getting an academic collaboration stood up with Avista that looks like typical, peer-to-peer collaboration ain't going to happen. It might be an interest area of Avista, and you might go off and publish on your own with their funding, but you're not going to develop a company collaboration with them. At least it doesn't look like there are many roots to it. And then the other thing that was interesting about this is if you look at the titles, it looks like history, right? So it's interesting. On the other end of the spectrum are companies like Microsoft, right? So let's do that. So Microsoft, almost 5,000 hits, right? And you look at them just at this level. You look at them, you can scroll down, you can see what other organizations they interact with. So Microsoft, right? Lots of universities, even other companies. So they do lots of publication. They do lots of publication with collaborators at other places. That's what this tells me. So that's great. But this is looking at 5,000 publications from Microsoft is not very useful. You can filter within here using keywords. I'm not going to go to that right now. But quick little one that this tool allows you to do is you can drill into where they publish by kind of broad area. And then this allows you to kind of drill down into that further. So, you can then do this again, right? And you're getting more and more detailed areas underneath. So now this is telecommunications, but this is computer science and software engineering associated telecommunications, right? So very powerful tool, really quick way to get into a company and understand where they're working. Little point of caution. Oh, bummer. There we go. The keywords can be very finicky in this database. So try a number of them before you give up. And then also they allow you to do some wildcard searching. But this is kind of the snapshot of Web of Science. And I think it gets you a feel. One of the great things is when you do find a publication of interest, a lot of these are academic publications. right? So you kind of can also get down here and where is it? Document types, right? Say I want to only look at their articles. Then you could further look at where they publish. So there's a lot of, where they publish. So there's a lot of different directions you can come at this with to find the right person. And again, once you're looking at a specific publication that's relevant to your work, now you've got the names of the author, and usually there's a correspondence address. So you kind of pay channel. If you can't find a correspondence address, that's where, go back to Google, start working with that. When you're down to the level of individual, that's where LinkedIn kind of comes in handy. It's a tool for searching people. I have a profile. Most people in industry also have profiles. One of the things that I like to do with this, let's just do PACCAR. You can search companies and you can find people in the companies. I just typed PACCAR into the search, ended up with the PACCAR page. If I go to people, now this is people who are on LinkedIn that have an association with PACCAR, either current or former. You can further filter by things like, say I want to find somebody who's got a mechanical engineering specialization and is a Washington State grad, because it's easy for me to reach out and say, hey, I know you graduated from WSU and you're working at PACCAR. I'm a professor of ME at WSU. I'd like to talk to you about something. So now you're down to 13 people that you've identified in PACCAR. Now it's a matter of title. So here's the 13 people. Do you want to go reach out to the senior vice president of PACCAR? Probably not. Would he be powerful and get you to the right person if he had the capacity and interest to engage? Absolutely, but what's your likelihood of getting a response? Very low. Here's a title that looks pretty promising: engineering supervisor. Probably somebody with some decision-making ability, probably oversees a small group. Probably the right person to reach out to initially and say, hey, would you be interested in talking about whatever? Other end of the spectrum, not relevant titles: commodity manager, probably not a research person. Business analyst, probably not. Sales manager, no. Powertrain validation engineer. That's a very specific title, right? He does a very specific thing, probably not at the level of decision-making authority to bring in a new project, right? So when you're in LinkedIn looking at titles, you're filtering down to who do I specifically want to contact. So I hope that gives you a feel for what these different tools can get you. I'm going to jump back to the presentation.
Just while you're doing that, Brian, I'll also just chime in and comment on the fact that a lot of the business-oriented folks, while they may not be the people you end up working with, they can really help make connections. So business development managers, some of the analysts, some of those types of folks can be pretty useful for. It'll be a second level connection, but they can help you understand the organization of a large company like PACCAR to make sure you reach the right people fairly quickly.
That's a good point. I forgot to mention that the business development role is an important one, and it's often a non-technical role. But yeah, they're about routing and connection. Once you do figure out who you want to talk to, you got to craft a message. That's the next point. Yes, Daniel.
Super great advice. I just want to point out, for students that are trying to do market research about companies they want to work at, you have just nailed every single thing in terms of understanding the organization and the units and the people that might be titles and activities, everything you've done. Perfect. So thank you.
Appreciate it. So one of the things that's really important when you engage a company is you got to keep it tight and be to the point. Don't give them a 5-page email with bulleted work plan that you're thinking about. It's a message like this. It's simple. Just a few words, you know, who you are, what you're interested in, and what you want from them, right? So it makes the transactions super easy and makes the probability of getting a response very high, or a lot higher. So keep that in mind. I want to hit something that Daniel touched on. One of the golden things is in reaching out to companies is using students. You immediately disarm the interaction when you say, I am a student at, and I am interested in, because it becomes a non-competitive interaction. So in our I-Core site, we beat people over the head with it, and time again. That is a very successful approach. Aaron, did you want to add something?
No, I was just muting myself, not unmuting myself here. Go ahead.
Cool. Okay. So once you've got
having been in industry, that is absolutely the case. We just as much as a lot of folks that are professors, you know, we love to interact with students. We see them as, you know, potential future hires and interns, and yeah. So there's and just happy to do informational interviews and talk about what we do and all kinds of stuff like that. So I totally agree.
And to that point, when you do get that meeting, you want to spend the meeting listening, not talking. You want to be picking their brain and understanding kind of their problem areas and their needs areas. And it's very contrary to what professors usually do. You know, it's there. Professionally, what you do is you go to a conference and you talk to people about your work, and you tell them about that, and they get interested, and you have a conversation. It's kind of the flip here, where you need to be sort of the questioner. It's like, you know, I have this expertise in this area. You know, I really want to learn what problem areas you guys grapple with that touch this, and how that my work might interface with it. So it's really about listening more than talking. And what you're trying to do in listening is understand their business needs. You know, and that you don't have to be a business person to understand business needs, right? It's about costs. It's about, you know, potential revenue. It's about, you know, technical thing that can really solve a problem. So really what you're doing as you engage in this is you're finding your value proposition for them. You know, a value proposition is why should they care about your work? And the only way that you're going to get to that is by understanding what their needs and interests are. So that's why it's important to listen first, and then figure out where you can propose your value. Value propositions, they're actually a lot more complicated than you think. You know, people have a lot of trouble figuring out what the value proposition is. In our I-Core activities, we'll do 8 weeks of sessions, and people will continually tweak their value proposition, and it will end up looking totally different than what they walked in. But really what it's about is some kind of pain or gain, a pain relief or a gain creator for them. I'm going to jump to, and then not only is it pain or gain, it's like how much of a pain is it, or how little of a pain is it? And really what you want to be as you're exposing it or exploring this is kind of understanding where there's big deals and where they don't care. What you don't want to be is in this middle where they're kind of like, I'm not sure. Aaron likes this analogy. I think it's a good one, so I included it here. Aaron, you want to walk through it?
Sure. Yeah, sure. I think this came out of a board meeting one time at Energy 2, which was they were trying to urge us out of the not relevant and don't care part of the interaction, I think, and one of our board members highlighted this analogy. So there's a few different things that solve problems for people in the health environment. You've got painkillers, so you got things like ibuprofen and Tylenol, or on the more potent end, maybe a Vicodin or something like that. And those are things that take care of an urgent problem. They solve pain for people immediately, and people are willing to make some sacrifices in some cases to get rid of that pain. So painkillers are urgent problems that need to be addressed right away, and people are very hungry for painkillers in plenty of scenarios. Medicine or preventative medicine is really important. It'll fix a chronic problem. That's something that probably you will continue to take for a long time in certain cases. So that's worth noting. And so you'd be willing to pay for it, but probably not quite the sense of a deadline or urgency as you would have with painkillers. And then of course there's vaccines. So absent a global pandemic like we're all experiencing right now, vaccines are unfortunately somewhat less interesting. It's something that people will put off. They might decide to take it or not take it, and they probably should pay for it, but again, only if everybody else does. So this is in the research world that can relate to things like pre-competitive research or large areas where lots of folks in an industry are investing in the same research. So vaccines are a good thing, but it's probably not something that's going to move things along quickly. And so that's why I put that sort of speed ranking down there at the bottom. If you're looking to get something going and you can identify a painkiller that you can deliver, that's going to happen quickly. You might see businesses and industry folks respond in a matter of weeks or months, and they'll be calling you back and asking more, and following up with that next meeting real quickly and things like that. Whereas if you're delivering a vaccine, yeah, it may take years of work and interaction in order to get that to happen. Same sort of time frame as you see with the in the medical field. So
yeah. I like the analogy. It's direct. I mean, the way I look at it is painkillers are one thing, and medicine is like the game creator, right? It's going to take a little bit of work. You're going to save money in some way, but it's going to take a little longer to get to. And vaccines are the kind of like nice to have, right? Yeah, that'd be great. I'd love that, but I'm not going to jump out of my chair to pay for it. So the point of all of this, again, is to find your value proposition, and you do that by listening, right? You don't, I think you could probably look at this slide and guess which ones are the don'ts. You don't want to talk about your thing all the time. You want to ask some open-ended questions about the areas that they're looking to develop things in. And then, have some drill down questions prepped for that sort of tie it to the things that you're interested in. Where you can ask about experiences in interacting, and this is kind of the thing that I mentioned earlier. One of my first questions is always, have you worked with the university before? And that tells me a ton about how I need to approach it. And then always the last question, is there anything I should have asked? That's a great open-ended question. It gives them a chance to say what's on their mind, and you listen very carefully if you get a response to that one. Some just quick, there are a lot of words in this slide, but some examples of what I mean when I'm talking about good questions, right? Bad questions are ones that have an obvious answer. Do you like sunshine? Yes, I like sunshine, right? You don't want to ask questions that's got kind of the pre-baked answer to it, where it's a yes, no that validates something that you want to hear. These are great examples of not good questions, right? Who doesn't want to save lives of people, right? This is a question that's basically, you're trying to sell something, right? And you're not interested in selling something. What do you learn from them when you ask a question like this? Here's an example of open-ended ones, right? In your experience, right? So you're asking them to give them a narrative, and then you've got some drill down questions underneath it. This is a sort of business process question. And, you know, an analogy in the sort of non-software space is like, how often do you, resupply your stock of blah? And what are the factors that you care about when you resupply your stock of blah, right? And kind of gets you down into the weeds of their operation. So I think that I hope that gives you a good idea of sort of what questions should look like. Getting close to end of time, so I'm going to pick it up a little bit. These are best done one-on-one. Don't do these in a group. At least on the company side, you're getting one person's perspective. Again, listen. Pare it back. This is a great one. When you hear something that's important, when you hear about a pain that they've got or a gain that they need, you want to verify it. Verbally say, hey, if I hear you right, it would be really useful for this to be changed to that, right? And those moments are the ones where you start to frame your project. You understand where it's going to hit them, and you want to echo back and make sure that that's the right thing. Okay, I'm going to jump that. Okay, so in the remaining minutes, I've got just a few things on interacting with the university. Once you've got something important, you're going to now need to sort of start scoping down into what a project looks like. Companies like to see deliverables and milestones. Give them a broke out. For $10,000 in 2 months, I'll have this. With 20 more thousand bucks in 3 months, I'll have this, right? And design it to be modular. Allow them to sort of cherry pick. I always point to F&A, a common problem that makes projects go sideways all the time is people don't factor that into their initial estimate. They either don't factor it in and say for $50,000, I'll get you to this point. And then they move the contract through the university and figure out that they're only getting $33,000 because a big chunk of it got eaten by F&A. They got a problem. Now they're over-promised to the company, and they're under-resourced to do it. So get ahead of the F&A question by factoring it into what you quote. It makes it a lot easier. Most companies are fine with it. You just got to figure it into the cost. It's the cost of the operation. Always be realistic and pessimistic. Never overpromise. That's the worst thing to do. In these kind of interactions, because especially when you're starting a new research collaboration, it's about the ability to deliver, and your trust is based on your ability to deliver. So that's a super important. Intellectual property is going to come up in every company discussion. University, if you work at a university, they're going to own the intellectual property that you use. The company's going to want to be looking for some route to use it. There's almost always a way. It's a matter of pulling the right person into the conversation. I solve intellectual property problems for WSU all the time. I'm pulled in when it's sideways. There's always a way to do it. It shouldn't be a barrier, but companies care deeply about it because if they're going to put money to a project, they're certainly going to want to use the product, right? And it, completely understandable position. And that can be difficult if the university owns it. You're going to have to do some kind of agreement with them. You might need to do it early on in the process to understand in more detail what their problems are. They might ask you to sign something like a confidentiality agreement before you even do an interview. Those are agreements that your university is going to work with you on. There's probably a central office in each of the universities involved that does these types of agreements. It's confidentiality is really common, especially in the engineering spaces. They're going to want something. Materials transfer agreements are a little less common. in the spaces that you're working on, these are for situations where you're physically going to exchange materials and people want to control access to the materials they exchange. And they might involve terms to like return it and destroy it and stuff. Project agreements are when you actually have an agreed project, you've scoped it out, you got a white paper with the bullets and delivers, and they want to do it, and they, your dollar numbers are agreed. Now you need a document that outlines the timelines for delivery, the abilities to publish, the intellectual property rights tied to the project, and indemnification, termination, all the, that's a 15-page agreement that's got a bunch of detail in it. Just in the name of finishing by 11, I'm not going to talk about each one of those three in detail. A few comments, publications. Most universities are pretty rigid on publication in that we will not agree not to be able to publish. Oftentimes that's a misunderstood thing at the faculty level. What we will do is we'll allow the company to delay a publication and hold back for 30 days so they can review it to see if there's anything they want to go after a patent around.
I'll just chime in on that real quick too, because one thing that we fail to notice sometimes in the university is that a patent is a publication. It's not the typical scientific literature publication that we all aspire to most of the time, but it's been published. So it's something within the university that you can kind of consider. And then the other thing is that, yeah, sometimes you just have to wait. If you wait a little bit, people can pull together a patent application that preempts that scientific literature publication. So just waiting for a few months for the company to get their patent filed, and they'll basically just, you could give them a draft of the scientific publication before you actually release it, and they can make sure all that material is included in their patent so they're covered. It's really not too hard to get around.
Yeah, and I mean, it's the kind of thing you want to do to be a good collaborator, right? Because again, the whole premise of you interacting with them is that you add value to their business, right? And you're a good collaborator when you add value to their business. And part of adding value to their business is making sure that they've got protected what they need protected, right? And so that's an important sort of component of the interaction.
Yeah, and
so
it can be a win-win too. A lot of these folks have, they've had experience in R&D in the past, and they might miss the scientific publication or would like to have a scientific publication, or their junior staff might like to have that, that publication on their resume. So it's just taking a little extra time to do both is valuable.
So that's the last of what I got. I hope that was a useful session to kind of the 101 of trying to build an industry collaboration. If people want to reach out to me and talk about specific aspects, I'd be more than happy to get on the phone or get on a call. So thanks, Aaron, for the invite. Hope it was helpful to the group.
Absolutely. Thank you very much, Brian. It was great.